What's going on, everybody? Mr. Barry here with Algebra 1 and our adding, subtracting, and multiplying polynomials week. And what I'd like to do here is just go through some more adding and subtracting examples. As you can see on the screen currently, I have two sets of problems, one where there is a plus sign in between two parentheses and one where there's a minus sign between two parentheses. In both situations, I'm doing certain operations to two binomials. We know a binomial has two terms. So in the first parenthesis, 7x plus 7, that's a binomial. In the second parenthesis, 4x minus 4, that's a binomial. So I'm going to go ahead and start off the problem. Now, since I have the parentheses there, technically both sets of those parentheses have some sort of number in front of it that we need to distribute. Here it's the number 1, so that it's not going to necessarily look too different after we get done with the distribution, because we know that when we multiply anything by the number 1, it's just going to be the same exact thing. So I have 7x plus 7 over here after I distribute that 1. And then over here, 1 times 4x would be 4x. 1 times negative 4 would be negative 4. So in that situation, you could say to yourself, well, if I just remove the parentheses, it would be the same exact thing as I see there. And that's true for that particular example. And we'll see here in a second why that doesn't always hold true. But at this point, all I want to do is combine like terms. There's no multiplication left in the problem to do. And we would like to put this in the descending order as possible with our constant last. So I see that 7x. I see that positive 4x. And if I just combine like terms there, 7x plus 4x is 11x. And then I have the plus 7 and the negative 4. I just like to label them somehow. I just use a triangle. 7 minus 4, if we're combining like terms, would be plus 3. There's no combining those. I can't add 11x plus 3. They're not like terms. That's as far as I can go with my simplification here. It's 11x plus 3. In the next example down, very similar in that both of those parentheses would technically have a 1 in front of them, but the second parenthesis, it's not really a 1, it's actually a negative 1 because of the minus sign separating the two parentheses. So we know this is some sort of subtraction going on here because of the minus sign in between the two sets of parentheses. But let's go ahead and distribute the 1s out. And previously, same exact thing here, 1 times 7x is 7x, 1 times 7 would be positive 7. Here, however, we got to be careful. I'm distributing negative 1, not positive 1 like the previous example. Negative 1 times 4x would be negative 4x. Negative 1 times negative 4. If there's a mistake to be made in this problem, my assumption would be that would be the spot. Negative 1 times negative 4 would be positive 4. Again, we've kind of gotten rid of all the parentheses in the problem. There's no more multiplication. All I can do is combine like terms here. Do note, though, how it changes from one problem to the next. Here, when I combine my terms that involve variables in them, I got 7x and negative 4x. If I combine that, 7x minus 4x would be 3x. And then here, instead of having the 7 minus 4 like I had in the previous example, it's 7 plus 4, because when I distributed negative 1 times negative 4, that gave me a plus 4. So that would be a positive 11. Again, no adding can happen at that point. We have 3x plus 11. That's as far as we can go with that simplification. I want to continue on here. Again, two examples that I have two binomials separated by, in the first example, a plus sign. In the second example, I have it as a minus sign. And you don't really need to write these ones out here all the time. I like to do it just to kind of give myself a reminder that technically there is some sort of distribution, and not really with the first parenthesis, more so the second parenthesis, and especially in that second example we're about to do down here at the bottom. But this first one, distribute positive 1 both sides, or to both parentheses, and it kind of holds true to what we have seen in the parentheses. I have 8n squared minus 1 plus 6n squared minus 7n. And I want to combine like terms where possible. Now remember, our like terms here are the same exact variable with the same exact exponent. So here I have an 8n squared and this plus 6n squared, both variable n, both with an exponent of 2. So I can add those two. I can combine like terms with that. 8n squared plus 6n squared would be 14n squared. I have a -1 and a -7n left. Those are not like terms. And again, I want to try to put this as much descending order as possible. So I have my -7n first. And then after that, I'll go ahead and put in my -1 as a constant in the back end. So and if you can look over here, I have 14n squared minus 7n minus 1. None of those are like terms. They all have different types of exponents. We have that constant -1 in the back end. So that is as simplified as possible. We actually end up there with a trinomial, 3 terms there, as our simplified answer. We'll go to the next one down, and we're going to go ahead and distribute our 1 to the first parenthesis. We have 8n squared minus 1. Here's where we need to be careful. I need to distribute here my -1 because of the minus sign in between the two parentheses. So -1 times 6n squared would be -6n squared. And again, if there's a mistake to be made, I would guess it would be here. -1 times -7n would be positive 7n. No more distribution or parentheses involved here. Let's go ahead and combine like terms. 8n squared, this times it's a minus 6n squared. So 8n squared minus 6n squared would be 2n squared. 2 terms left. 7n has a variable, so it's now a plus 7n when I distributed it previously. And then I'm going to wrap it up with a -1 as my constant. So hopefully you're starting to notice the difference between the two, where we see the same exact quantities, but there's a plus sign in between one of them, there's a minus sign in between the other one of them, and how that kind of changes things up. Would like to do one last example here. We do have a binomial now with a trinomial. So we have a quantity of 2 terms getting added in the first example and subtracted in the second example to a quantity with 3 terms in it. So same exact process as before. I like to stick a 1 in the front just to kind of give myself a reminder of what's going on in the problem. Distributing that 1 here with the plus sign isn't the most terrible thing, because we're pretty much just jotting down the same exact thing that we saw in the parentheses. We look for like terms here. We like to look for the one with the biggest exponent first. I have a 4x squared, and it's the only exponent that has a 2. So I'll write that down first. Now I have a couple I have a couple terms here where there's just an x, and the exponent would technically be 1. So I have 2x minus 3x, and if I combine like terms there, 2x minus 3x would be minus x, or you could write it as minus 1x. And then finally, I have 2 constants at the end here. I have a -1 and a +2, and if I combine like terms, -1 plus 2 be positive 1. There's no simplifying that further. There's no like terms left in that. 4x squared minus 1x plus 1 is my final answer. We'll wrap it up here. Same exact quantities. However, now I have a subtraction symbol in between the two. So when I get to this point and I have to distribute, I got to be careful because it's a -1. So -1 times 4x squared would be -4x squared. -1 times -3x would be positive 3x. And -1 times positive 2 would be -2. We find like terms. Again, my biggest exponent that I see in the problem here is the number 2. -4x squared will go first. Then I go down. My next exponent that I see here is technically the 1. So we have a 2x and a positive 3x. So 2x plus 3x would be positive 5x. And then I'll wrap it up with my constants, negative 1, negative 2. So I have negative 1 minus 2. That's 1 negative with 2 more negatives would make a total of 3 negatives. Nothing more to combine there, different exponents, not like terms at all with any of those. I have it in descending order for both examples, so I'm really happy about that.